In Chapter 6, we're going to study integration and one application of integration, which is area between two curves. In 6.1, we're going to look at antiderivatives, otherwise known as indefinite integrals. In Chapter 5, we evaluated definite integrals that look like the following. And if you remember to do this, all we did was we integrated each part of my integrand, and then I evaluated it by plugging in the upper limit for x, and then I subtracted the lower limit for x, and this was my answer. So 16 plus 12, this works out to be 28, subtract 4, so my definite integral was 24. In this section, there's not going to be any limits that we're going to deal with here, so we're going to end up with an equation, not an equation, but an expression for the antiderivative of a function. And these are some of our basic integration rules that we used. Okay, and if you notice on the left here, if I was to zoom in, these are all my derivative rules on the left that we've taken. And on the right are going to be my basic integration rules. So if I highlight these, and again, we did a lot of these integration rules when we did definite integrals. So the same rules apply. Now we're just applying it to indefinite integrals. So let's take a look at an example. In this section, in this example, we want to find the general antiderivative of the following. So this is my function. And before I can take the antiderivative, I must write it without the radicals. So basically, I want to find the antiderivative. So I want to find the integral of x to the 1/2 plus x to the 1/3 dx, meaning with respect to x. So we're going to follow the same integration rules that we did before. We're just going to add 1 to the exponent and divide by the new exponent. So if I add 1 to 1/2, it's 3/2. Divided by 3/2 is like timesing by 2/3. So that would be the integral of my first part here. And then I'm going to add the integral of x to the 1/3, which if I add 1 becomes 4/3. Dividing by 4/3 is like timesing by 3/4. And then I'm going to add a constant. Now, some of you might be wondering, what's that plus c mean? Well, when you take an antiderivative or an indefinite integral, if I take the derivative of my final answer, I should end up with what I started with. And if I take the derivative of my first two terms, I will end up getting this. And the derivative of a constant is really 0, so I could have any constant there. And later on, there are some questions where we can find what the actual constant is, but it's important that you put that plus c at the end for your indefinite integrals. Okay, in our next example, I want to rewrite this. Again, this is really 3 over x to the 4/3 dx. And then I want to move that x to the 4/3 up to the top. So it becomes negative. Now, if you want, you could take this 3 and move it out front. You could integrate your x to the negative 4/3 and then times it by 3, or you can keep the 3 inside as personal preference. But if I add 1 to negative 4/3, I'm adding 3/3, I'm going to get negative 1/3. And therefore, I have to divide by negative 1/3 plus a constant. If I multiply 3 by the reciprocal of negative 1/3, I'm going to get negative 9 x to the negative 1/3 plus a constant. Again, if you take the derivative of this, you will end up with what we started with. Okay, in this next example, we're given secant squared t plus t squared, and our function is defined in terms of f of t. So I'm going to integrate secant squared t plus t squared dt. And you have to ask yourself, what function, when I take the derivative, do I get secant squared? Well, remember our trig derivatives, that would be tan t plus t squared is the basically like the power rule. I add 1 to the exponent and divide by the new exponent plus a constant, and there would be my final answer. Okay, this time we have f double prime x, and we're asked to find f of x. What we need to do here, first of all, to find f prime, that is going to be the integral of f double prime, which is x squared plus x cubed dx. So therefore, f prime is going to be x cubed over 3 plus x to the 4 over 4. That's a constant. Now my question is asking me to find f of x, so that means I have to integrate f prime. So f is going to be the integral of 1/3 x cubed plus 1/4 x to the 4th plus c with respect to x. So if I add 1 to the exponent, I'm going to get 4. If I divide by 4, 4 times 3, this is going to be 1/12. If I add 1 to the exponent, I get 5. If I divide by 5, 4 times 5 is going to be 20. If I integrate a constant, it's going to be a constant of x plus another constant, which I'll call d. And this would be my final answer. Okay, initial value problems are one where they give you a certain value of the function, and we can use this to help us find c, as we'll see in this example. So we're asked to find f of x, and we're given f prime. So to find f of x, we're going to have to integrate f prime with respect to x. So the integral of 4x is going to be 2x squared. Integral of 3 is 3x plus a constant. Now they're giving me a value of the function, and that means when x is 0, the function's value is -9. So -9 is equal to 2 times 0 squared plus 3 times 0 plus a constant. So my constant works out to be -9. So now I can rewrite my function as 2x squared plus 3x, and in place of the constant, I'm putting -9. And the only reason I could find the constant is they gave me a point on the function. So lots of people will find the constant, but they'll forget to rewrite the function with the constant in it. So this would be your final answer. Okay, this one, we're given f double prime, and we want to get all the way back to f again. So the first thing I have to do is I have to integrate or find f prime, which is going to be the integral of f double prime. So f prime is going to be, the integral of that is going to be 5x to the 4th minus 10x plus a constant. And because I'm dealing with f prime, I'm going to use the condition with f prime, which says when x is 1, f prime is -5. So I'll put a -5 into this side. 5 times 1 to the 4th minus 10 times 1 plus a constant. So this ends up being -5 equals -5 plus a constant. If I add it over, my constant is 0. So f prime is going to be 5x to the 4th minus 10x. I don't need to put plus 0 because it's a 0. So now to find f, that's going to be the integral of f prime. Again, if I add 1 to the exponent and divide, I'm going to get x to the 5th. Add 1 to the exponent and divide, I'll get 5x squared plus a constant, and that's my function f. And now they've given me another condition that when x is 1, y is 1 on the function. So I put a 1 in place of my function, and I'm also putting in a 1 in place of x. And if I evaluate this, this is going to be -4. If I add 4 over, I get 5. So my final answer for my function f of x is going to be x to the 5th minus 5x squared plus 5. Okay, our next example is a little bit of a trickier one. Okay, so the first thing I'm going to do here is I'm going to factor a 3 out of the bottom. And then I'm going to bring the 1/3 out front. So it's the integral of 1 over x plus 4 dx. Now, you might be inclined to try this. You might want to move that x plus 4 up to the top. and then try and integrate. But if you added 1 to -1, you'd get 0, and dividing by 0 you can't do. So obviously that is not the correct process. Now, this is a special case for integration. Again, if you recall from derivatives, what function, when I took the derivative, did I go 1 over the function? And if you recall, that was the logarithmic function. So in this particular case, this is going to be 1/3 ln, the absolute value of x plus 4, plus a constant. Now, the reason we can go straight to a logarithmic function is because the derivative of this x plus 4 is equal to 1. And we'll talk about more complicated logarithmic integration questions when we get into u substitution in the next section. But there would be my final answer, and this answer matches up with B. Okay, taking a look at this one, I have the integral of 5e to the 2x plus 1 over x dx. So again, I'm taking the integral of each part. So the integral of an exponential is going to be itself. And when we're integrating, we divide by the derivative of the exponent. So the derivative of the exponent is 2, so I divide by 2. And the integral of 1 over x, well, we just talked about that in the last example, that is ln x plus a constant. So my answer is going to be B. Okay, this question, we have a particle moving along the x-axis with a velocity given by v of t is 3t squared plus 6t. If the particle is at position 2 at t0, what is the position of the particle at t equals 1? Well, we can think of this as an initial value problem. So we could say that to find the position, that's going to be the integral of my velocity function. So my position function is going to be t cubed plus 3t squared plus a constant. Then I could use this as my initial condition to find my constant. So I could say that when t is 0, the position is 2. So 0 cubed plus 3 times 0 squared plus a constant. So this is all 0, so my constant is 2. So my position function is going to be t cubed plus 3t squared plus 2. And now let's answer the question, what is the position when t is 1? So I plug 1 into here. And if I work it out, I get an answer of 6. Okay, next example, same type of question. So I want you to pause the video and give this one a try. Okay, hopefully you've had a chance to pause the video. So again, a particle moves along the x-axis with a given velocity. They're telling us the particle is at position x equals 0 at t equals 1. So this is like an initial condition, and they want the position at 0. So again, to find the position function, I'm going to integrate my velocity function. So this is going to be t cubed minus 7t plus a constant. And I'm going to use the initial condition that when t is 1, the position is 7. So if I add 7 and subtract 1, I'm going to get my constant is going to be 13. So S of t is t cubed minus 7t plus 13. And now if I want the position at 0, it's going to be 0 cubed minus 7 times 0 plus 13. So my position is at 13 at time 0. So that means I started at a position of 13 units away from the origin at t equals 0. Okay, next example is a multiple choice question again from another AP exam, and it says a particle moves along a straight line. The graph of a particle's position x of t is shown above for 0 to 6. So this is the position function, x of t. The graph has horizontal tangents at 1 and 5. And remember, the slopes on the position is velocity, okay? And it has an inflection point at t equals 2. So there's my inflection point. So that's where my second derivative changes. And it says, for what values of t is the velocity of the particle increasing? Well, velocity of a particle increasing is the same thing as the acceleration. So we want to know if the velocity of the particle is increasing, when is the acceleration positive? And the acceleration is positive when our original function is concave up. And this is the graph of position, which is like our original function. And this graph is concave up from 0 to 2. So my answer is simply A. Okay, that ends this lesson. Okay, there is your assignment, the circled questions on this sheet. You'll get that handout in class. If you're not in class, you can refer to that video here, and there are the final answers for that assignment as well. Okay, good luck. If you have any questions, you can ask me the next day in class.